Here's a question that sounds stupid but isn't. What's actually holding everything together right now? I mean, really holding it together. You're sitting there, your body's made of atoms. Those atoms have a nucleus at the center, and inside that nucleus, you've got protons all crammed together. Protons are positively charged particles. And here's the thing about positive charges. They hate each other. They repel, like trying to push two magnets together wrong way round, except way more intense. Way more intense than you can imagine. So why doesn't your body just explode into a cloud of subatomic shrapnel? What's stopping every atom in existence from ripping itself apart right this second? When J. Robert Oppenheimer started digging into this question in the 1930s, what he found was so disturbing that it would eventually haunt him for the rest of his life. Because the answer isn't just surprising, it reveals something about the universe that honestly shouldn't be possible. Something that breaks every intuition you have about how reality works. And if this kind of stuff blows your mind, hit subscribe, because I'm just getting started. And what's coming next is going to change how you see literally everything around you, every object you touch, every breath you take. The force that's holding you together right now, the force that prevents reality from dissolving into chaos every fraction of a second, operates on principles that defy common sense. It's stronger than anything else in nature at short ranges, works at distances smaller than you can possibly picture, and contains enough trapped energy inside every atom that Oppenheimer realized we could either use it to power civilization for millennia or end civilization in an afternoon. He chose to find out which. And that choice, that moment of understanding what he was actually looking at when he stared into the heart of the atom, turned him into someone who'd quote ancient Hindu scripture about death and destruction because normal words, normal language, normal human concepts couldn't capture what he'd discovered about the fabric of existence itself. This is the story of the force nobody tells you about, the invisible hand that keeps reality from falling apart. Here's what they teach you in school. Matter is made of atoms. Atoms have a nucleus in the center with protons and neutrons packed together. Electrons orbit around the outside in neat little shells. The protons are positive. The electrons are negative. Opposites attract. Everything's balanced. The whole system is stable. Makes sense, right? It's a tidy picture. Clean. Understandable. Except, here's the problem nobody mentions in high school physics. The problem that bothered scientists for decades. Those protons in the nucleus aren't just sitting next to each other like neighbors in separate houses. They're packed together so tight that if you scaled up a nucleus to the size of a tennis ball, the individual protons would be separated by distances smaller than the width of a human hair on that scale. Actually, way smaller. They're basically on top of each other. And they're all positively charged. Every single one. The electromagnetic force, the same force that makes your hair stand up when you rub a balloon on it, the same force that creates lightning, the same force that powers every electric motor, says those protons should be repelling each other with incredible, violent force. The closer two charged particles get, the stronger the repulsion grows. It follows an inverse square law, meaning if you halve the distance, the force quadruples. If you reduce the distance by a factor of 10, the force multiplies by 100. And these protons are separated by distances so small that the electromagnetic repulsion between them should be astronomical. The electromagnetic force at that distance, at those separations measured in femtometers, should be ripping nuclei apart faster than you can blink. Instantaneously. Every nucleus should explode the moment it forms. But it doesn't happen. Your nucleus is stable. Every atom around you is stable. Something is overpowering electromagnetism, one of the four fundamental forces of nature, and holding these protons together despite their desperate attempt to fly apart in opposite directions. And whatever that something is, it has to be absurdly, ridiculously, almost impossibly powerful. Oppenheimer worked on this puzzle throughout the 1930s, studying under some of the greatest physicists in Europe, including Max Born in Germany. And when he started calculating the actual numbers involved, when he sat down with the equations and worked through the mathematics, he realized he was looking at a force that made electromagnetism look weak by comparison. The strong nuclear force, as it came to be called, is roughly 100 times more powerful than the electromagnetic force at nuclear distances. 100 times. That's not a small difference. That's not a minor variation. That's the difference between a firecracker and a bomb that levels a city block. And this force is operating inside every single atom of your body right now, holding together particles that would otherwise tear themselves apart, binding together the basic building blocks of matter against their electromagnetic will, creating a universe that by all rights shouldn't exist in stable form. Picture this. Imagine you're somehow small enough to stand inside an atomic nucleus. I know that's impossible, but stay with me because this thought experiment is going to blow your mind. You're standing inside the nucleus of a carbon atom, one of the most common elements in your body. There are 6 protons around you, each one about 1.7 times 10 to the negative 27th kilograms, which written out properly means 0.000, and then 23 more zeros before you get to the digits 1 and 7. Incomprehensibly tiny. Unimaginably small. These protons are separated by distances of about 1 femtometer, which is 1/millionth of 1/billionth of a meter. Written out, that's 0.000000000000001 meters. You literally cannot imagine something that small. Your brain doesn't have the evolutionary wiring for it. We evolved to understand distances we can see and touch, not distances a trillion times smaller than a grain of sand. At this scale, if you tried to push 2 protons together, the electromagnetic repulsion would feel like trying to push together 2 planets. The force would be unimaginable, overwhelming, impossible to resist. Every proton wants to get as far away from every other proton as physics will allow. But here's what's wild. There's another force at this scale, the strong force, and it's so powerful that it makes that planetary scale electromagnetic repulsion feel like a gentle breeze on a summer day. The strong force doesn't care about electric charge. It doesn't care that protons hate each other electromagnetically. It doesn't negotiate or compromise. It just grabs them, binds them, holds them in place with a grip that nothing else in nature can break under normal circumstances. Let me give you another way to think about it. Imagine you're holding 2 super-powerful magnets with their north poles facing each other. You can feel them pushing apart. Now imagine those magnets are 1,000 times more powerful. Now, 1,000,000 times. Now, 1,000,000,000 times. The force trying to push them apart is so strong that if you let go, they'd shoot away from each other faster than bullets. That's what protons experience from electromagnetic repulsion. Now imagine there's an invisible hand holding those magnets together anyway. A hand so strong that no matter how hard the magnets push, they can't separate. That's the strong force. Take a single uranium-238 nucleus. It's got 92 protons in there, all pushing against each other with electromagnetic fury. That's 92 positive charges, all trying to escape from each other simultaneously. The total electromagnetic repulsion trying to blow that nucleus apart is massive, catastrophic, enough to overcome almost anything. but the strong force is holding it together anyway. Barely. Just barely. Uranium is right on the edge of stability, teetering on the precipice. You can actually nudge it over that edge with a single neutron, and when you do, when you finally overcome the strong force holding those 92 protons prisoner, all that electromagnetic repulsion is suddenly free to act. The nucleus splits violently. That's nuclear fission. And when those protons finally get to fly apart, after being held prisoner for billions of years since the nucleus formed, the energy release is exactly what you'd expect from unleashing forces that were strong enough to bind together 92 mutually repelling particles against impossible odds. That energy is enormous, staggering, world-changing. Oppenheimer understood this better than almost anyone alive in the 1940s. He did groundbreaking calculations on neutron stars in 1939 with his student George Volkoff, figuring out the maximum mass a neutron star could have before gravity overwhelms even the strong force and the whole thing collapses into a black hole. They determined it was about 3 times the mass of our Sun. Why does that matter? Because neutron stars are basically giant atomic nuclei, cosmic-scale nuclei held together by the strong force and gravity working in competition. If the strong force could hold together something with 3 solar masses worth of neutrons packed into a sphere the size of a city before gravity finally wins and crushes it further, imagine what that force is doing inside regular atoms. The strong force is so powerful that it can resist the gravitational collapse of stellar remnants. Think about that for a second. Gravity is the force that holds galaxies together, that crushes stars into black holes, that warps space-time itself. And the strong force can hold its ground against gravity, at least for a while, at least until the mass gets too large. Every atom in your body right now is held together by this same force, this same absurd binding energy that defies one of the fundamental forces of nature and can stand up to gravity itself under the right conditions. And this is where Oppenheimer realized something that would change everything, something that would eventually lead him to a desert in New Mexico, and a moment he could never take back, a moment that would define the rest of his life and change human history forever. See, the strong force isn't just powerful. It's the most powerful force in nature at short ranges, bar none. Nothing even comes close. But here's the disturbing part. The part that makes everything else make sense and also makes everything more dangerous. It's also incredibly short-ranged. It only works across distances of about 1 to 3 femtometers. Outside that range, it drops to basically nothing, essentially zero. It's like a prison guard that's unbelievably strong, stronger than anything else in the universe, but can only reach a few inches beyond the bars of the cell. Inside that tiny sphere of influence, inside those 1 to 3 femtometers, it's dominant, it's overwhelming. It holds nuclear particles in an unbreakable grip that nothing can escape from. But step outside that sphere, move just slightly beyond that range, and suddenly you're free. The electromagnetic force has infinite range. It gets weaker with distance following the inverse square law, but never goes to zero, never stops acting completely. The strong force just vanishes. Now, you're probably thinking this sounds exaggerated, that fundamental forces don't just turn off like a light switch when you cross some invisible boundary. But that's exactly what happens. The strong force has a range, a hard cutoff, and outside that range it might as well not exist. And Oppenheimer understood what this meant. If you could somehow overcome the strong force, if you could break nuclei apart or slam them together hard enough to overcome the electromagnetic repulsion and get them into that range where the strong force takes over, the energy involved would be beyond anything chemistry could produce. Chemical reactions involve electrons shuffling between atoms, electromagnetic forces binding and unbinding, energies measured in electron volts. Nuclear reactions involve the strong force itself, energies measured in millions of electron volts. Million to one difference. That's why a chemical explosion from TNT and a nuclear explosion are in completely different categories of destructive power. They're not even playing the same game. They're not even in the same universe of energetics. Oppenheimer saw this. When he took over as director of the Manhattan Project in 1942, when he assembled a team of the brightest physicists in the world at a remote laboratory in Los Alamos, New Mexico, he wasn't just building a weapon. He was unlocking the energy that holds reality together at its most fundamental level. And while you're processing that, drop a comment telling me where you're watching from, what city or country, because I'm always curious where in the world people are who want to understand this stuff at a level that goes beyond what they teach you in textbooks. People who want to know what's really happening beneath the surface of reality. By 1945, Oppenheimer and his team at Los Alamos had figured out the exact configuration, the precise geometry and timing needed to make uranium or plutonium nuclei split in a chain reaction. The principle is straightforward once you understand the forces involved, elegant even. Uranium-235 is unstable enough, right on that edge of stability, that if you fire a neutron at it, the nucleus absorbs the neutron, becomes uranium-236, which is even more unstable, and immediately splits into two smaller nuclei. When it splits, it releases 2 or 3 more neutrons, plus a huge amount of energy, around 200 million electron volts per fission. Those neutrons fly out and hit other uranium nuclei. Those split. More neutrons, more splits, more energy. Exponential growth. If you have enough uranium in one place, the critical mass, which for uranium-235 is about 52 kilograms, and you compress it enough or arrange it properly, the chain reaction becomes self-sustaining. Every nucleus that splits makes more nuclei split. In less than 1/1,000,000th of a second, in a time frame so short that nothing human can comprehend it, you go from a stable chunk of metal sitting quietly to a fireball hotter than the core of the sun. Oppenheimer knew this would work. The physics was clear, the mathematics was sound, the theory was ironclad. But knowing something theoretically and seeing it actually happen, witnessing it with your own eyes, are profoundly different things. On July 16, 1945, at 5:29 in the morning, in the New Mexico desert near Alamogordo, at a site they called Trinity, they detonated the first atomic bomb humanity had ever created. Oppenheimer watched from about 6 miles away, standing in the pre-dawn darkness with his colleagues, waiting to see if their calculations were correct, or if they'd made some terrible error. The bomb's yield was equivalent to about 21,000 tons of TNT. For context, the largest conventional bombs of World War II, the so-called blockbusters, were about 10 tons. This was 2,000 times more powerful. The temperature at the center of the fireball reached roughly 10 million degrees Fahrenheit, hotter than the surface of the sun, hot enough to turn sand into glass, hot enough to vaporize metal, hot enough to briefly recreate conditions that normally only exist in the cores of stars. The light was visible over 200 miles away. People in distant towns saw the flash and thought the sun was rising early. The shockwave was felt 100 miles away, rattling windows and knocking objects off shelves. A blind woman reported seeing the flash, the light so intense it penetrated her closed eyelids. People reported seeing the bones in their hands as the light shone through their flesh like an X-ray. And Oppenheimer, standing there watching this manifestation of the strong nuclear force, this release of binding energy that had been locked inside matter since those uranium atoms formed in the heart of dying stars billions of years ago, he went quiet. Completely quiet. His colleagues said he looked like he'd seen something beyond human comprehension. Later, he would say, "We knew the world would not be the same." A few people laughed, a few people cried, most people were silent. And he would quote the Bhagavad Gita, the ancient Hindu scripture he'd studied and loved, saying, "Now I am become death, the destroyer of worlds." That quote is from a scene where the god Vishnu is trying to persuade a prince to do his duty and takes on a terrifying multi-armed form to show his true nature. Oppenheimer identified with that moment. He'd revealed something about nature that couldn't be unrevealed. He'd shown humanity what was possible when you understand the forces holding atoms together. And here's what got to Oppenheimer. What haunted him for the rest of his life. What kept him awake at night and made him oppose the development of even more powerful hydrogen bombs. The force holding your atoms together, this strong nuclear force that's keeping you from flying apart into subatomic particles right this instant, contains energy so concentrated, so impossibly dense, that a piece of uranium the size of a baseball can level an entire city and kill 100,000 people. Every atom is a tiny prison of energy. The strong force is the jailer, the warden, the guard keeping that energy locked up. And we found the key. We learned to pick the lock. This isn't abstract physics happening in some lab somewhere far away from you. This is happening inside you right now. The carbon atoms in your body, the oxygen you're breathing, the calcium in your bones, the iron in your blood. Every nucleus is held together by the same force that Oppenheimer unleashed in the desert that morning in July. You're made of trapped energy, enormous energy, staggering amounts of energy compressed into tiny spaces. If you could somehow convert all the mass in your body directly to energy using Einstein's famous equation, energy equals mass times the speed of light squared, you'd release enough energy to power a large city for weeks, maybe months. Of course, that's impossible under normal circumstances, thank God, because if it were easy, we'd all be walking atomic bombs. But the fact remains, you're not solid matter in any meaningful sense. You're energy in a temporary configuration, energy held in balance by forces we barely understand. Even now, decades after Oppenheimer, the strong force keeps your nuclei stable. Electromagnetism keeps your electrons bound to those nuclei and allows atoms to bond into molecules. Gravity keeps you on the planet. The weak nuclear force allows certain radioactive decays that play crucial roles in stellar nucleosynthesis. You exist at the intersection of fundamental forces that are constantly in tension, constantly balanced on a knife's edge. And Oppenheimer realized this tension, this balance, could be exploited. 3 weeks after Trinity, on August 6, 1945, the United States dropped an atomic bomb called Little Boy on Hiroshima, Japan. The bomb used uranium-235 and had a yield equivalent to about 15,000 tons of TNT. 3 days later, on August 9th, another bomb called Fat Man was dropped on Nagasaki. This one used plutonium-239 and yielded about 21,000 tons of TNT. Estimates vary depending on the source, but somewhere between 130,000 and 220,000 people died from these two bombs, most within the first few months from the immediate blast, thermal radiation, and acute radiation poisoning. Entire cities reduced to rubble and ash by the same force that holds atoms together every day. The strong nuclear force, which exists to bind matter into stable forms, which makes chemistry possible, which makes life possible, was turned into a weapon of unimaginable destruction. And Oppenheimer carried that weight. He understood better than almost anyone what had actually happened. Not in a political or military sense, but in a fundamental physical sense. Not just the immediate devastation, the deaths, the suffering, but the fundamental violation involved. We'd learned to break apart what the universe spent billions of years building. We'd taken the glue holding reality together and turned it into a crowbar to smash reality apart. Years later, in 1954, during his security clearance hearing, Oppenheimer would say, in some sort of crude sense which no vulgarity, no humor, no overstatement can quite extinguish, the physicists have known sin, and this is a knowledge which they cannot lose. He understood on a level that most people never could. The knowledge of how to unleash nuclear forces can't be unknown. Once humanity knows what's holding atoms together and how to break that bond, we can't go back to innocence. The atomic age isn't just about weapons or power plants or medical isotopes. It's about a fundamental shift in our relationship with matter itself, with the physical world. We're no longer passive observers of nature. We're not even just manipulators of chemistry and mechanics like we were before. We've become capable of reaching into the nucleus, into the very foundation of physical reality, into the realm of forces that operate at scales smaller than we can visualize, and rearranging it according to our will. That's power beyond anything previous generations could have imagined. So next time you look at anything, a table, a wall, your own hand, a person you love, remember what's actually holding it together. It's not solidity in any conventional sense. It's not some mystical life force flowing through things. It's a fundamental interaction so powerful that it can resist the mutual electromagnetic hatred of protons, so concentrated that it contains city-destroying energy in every atom, so strange that it only works across distances smaller than we can visualize, so short-ranged that it vanishes completely if particles separate by just a few femtometers. The strong nuclear force is the answer to what keeps the universe from flying apart. And the answer is both beautiful and terrifying. Beautiful because it means existence itself is an act of constant creation, energy bound into stable forms by forces operating at scales beyond human intuition, beyond anything we evolved to understand. Terrifying because that stability is contingent, dependent on conditions remaining within certain bounds, and we've proven we can push things outside those bounds whenever we want, whenever we decide to. Oppenheimer saw both sides of this truth. He saw the elegance of nuclear physics, the mathematical beauty of how forces balance at the quantum scale, how nature uses the strong force to build up the periodic table of elements in the hearts of stars. And he saw the applications, the practical reality of what happens when you understand these forces well enough to manipulate them for human purposes. He spent the rest of his life caught between pride in the scientific achievement and horror at the moral implications of that achievement. In 1954, his security clearance was revoked in a humiliating public hearing, partly because of his past communist associations, partly because he'd opposed the development of the hydrogen bomb, which would be 1,000 times more powerful than the bombs dropped on Japan, and partly because powerful people in the government didn't trust him anymore. The government he'd served, the country he'd helped protect, turned on him. But even that couldn't erase what he'd learned, what he'd revealed about the nature of matter and energy. The strong force is still there, still holding every atom together, still containing absurd amounts of energy in tiny packages, still waiting for anyone with enough knowledge and resources to unlock it. Can you look at physical reality the same way after knowing this? Can you hold something in your hand, feel its weight and texture, and not think about the forces keeping it from disintegrating? Can you see matter as solid when you know it's mostly empty space held in temporary configuration by interactions we barely understand? If your existence depends on the strong nuclear force maintaining its grip on every nucleus in your body, and that force can be overcome by humans with the right knowledge and the will to use it, what does that mean for the permanence of anything? If this video changed how you see reality, smash that like button so I know this stuff matters to people. And if you want to keep going down this rabbit hole with more discoveries from Oppenheimer and other physicists who saw things most people don't know about, hit subscribe and turn on notifications because there's new revelations every week about the hidden forces that make reality possible. Drop a comment telling me which aspect of nuclear physics you want explored next. Thanks for watching.